Hey all, we're here to talk about the trigonometry part of our right triangles unit. And trigonometry basically is a way to relate angles and triangles to the side lengths in triangles, specifically speaking about right triangles. So we have three trig ratios that we're going to talk about. If you go further and take Algebra 2 trig or take a trig class at some other point, you'll learn about some other trig ratios. But for now, let's stick to sine, cosine, and tangent. And in a right triangle, we're going to have a leg opposite the angle we're talking about, a leg that's adjacent to the angle we're talking about, and we're always going to have a hypotenuse, which is across from the right angle. So the sine is the opposite leg. It's a ratio of the opposite leg's length to the hypotenuse. And sine is abbreviated sin. Some people say sin, but we pronounce this sine. And this symbol here, this sort of zero with a line through it, that's called theta. And that's a Greek letter. And we usually use theta in trigonometry when we're referring to an angle. It's just like using x. It's a variable, but it's common to use this Greek letter theta when we're talking about angles and triangles. So the sine, which is a function, so sine of theta is equal to the length of the opposite side in the right triangle over the hypotenuse. The cosine of theta, the cosine of some angle, is the adjacent side length over the hypotenuse length. And the tangent of theta, so the tangent of some angle, is equal to the opposite side length over the adjacent side length. So there's a few sort of tricks to remembering these relationships. Some people like to use the trick SOH-CAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then TOA, tangent, is opposite over adjacent. So TOA. I think that's a way a lot of people like to use to remember these three relationships. Of course, you have to know what those letters mean. You don't have to know how to spell those silly three-letter words, but it is usually pretty helpful. So TOA. So let's see a good example of this. So first I want to find the three ratios for angle A. So I'm going to come over here and I'm going to just point out we're talking about angle A. The first thing I always recommend doing is figuring out which side's the hypotenuse, which side's the opposite side, and which side is the adjacent side. The hypotenuse should be pretty easy. We've been finding hypotenuses for quite some time now. It's the side that's across the triangle from the right angle. Boom, there's the hypotenuse. And the opposite side is just like finding the hypotenuse. We're going to talk about the side that's opposite of the angle we're referring to. So in this case, if we start at A and go through the triangle, we'll find that this is the opposite side, and that leaves this side being the adjacent side. So we can now find the ratios for the three trig functions. So sine is opposite over hypotenuse. And here we're talking about angle A, so we can say the sine of angle A is O over H, which is 4 over 5. Cosine is A over H, so 3 over 5. And finally, tangent O over H, opposite over adjacent, gives us 4 over 5. So once we have our triangle labeled based on the hypotenuse, the opposite, and the adjacent, then it's pretty easy. If you know SOH-CAHTOA, if you know these three trig ratios, it's pretty easy to just plug in the side lengths and find the ratios. And of course, if you can, you should always simplify these. So we can't reduce 4 over 5, 3 over 5, so we just leave them like that. We can do the same thing for B. this time we're going to talk about angle B. Our hypotenuse is going to be the same. It's the side AB, which is 5 long, is still across from the right angle. But now our opposite and our adjacent sides are going to be different. This time, this side over here is opposite from angle B, leaving the side that is 4 long adjacent to angle B. So our trig ratios are going to be different for angle B. So we're still using SOHCAHTOA. Sine is 3 over 5. Cosine is 4 over 5. And I did the little error there. That should be adjacent over hypotenuse. And the tangent is 3 over 4. And also I need to come back here. Hopefully you were wondering, this opposite over adjacent for tangent of A should have been 4 over 3. So if you notice here, my sine and cosine for angle A are opposite for angle B. So the sine of A is the same as the cosine of B. The sine of B is the same as the cosine of A. And the reason I noticed my mistake is because the tangent of A and the tangent of B should just be reciprocals of each other. So tangent of A was 4 over 3, and tangent of B is 3 over 4. So once you know the sine, cosine, and tangent of one angle in a right triangle, it's pretty easy to find the other 3 ratios for the other angle. Go ahead and pause here, see if you can find the sine, cosine, and tangent of each of these angles in this triangle. Remember to use the previous example to help you. So if I'm looking at angle A, this side that's 17 is going to be my hypotenuse no matter what. 15 is my opposite side, and 8 would be my adjacent side. So that gives me a sine, which is 15 over 17, cosine, which is 8 over 17, and a tangent, which is 15 over 8. And just like I said on the last page, the sine and the cosine for angle B should just switch. So the sine of angle B will be the same as the cosine of A. The cosine of B will be the same as sine of A. So let's check that out. That is true. And just to make sure we're doing this properly, we'll check that the opposite side for B was 8, and the adjacent side is 15. So that's how I can get my ratios. And then tangent is just a reciprocal of the tangent of A, or opposite over adjacent using angle B, and you get the same thing. So here's your U-try. Write the sine, cosine, and tangent of both angle A and B. Use the previous 2 examples. Use SOHCAHTOA, and we will discuss in class.